Now this is the next question, and this is very interesting question. Very interesting question. And the question is asking, can you create DFA for this language? Can you create DFA to recognize addition? Can you create DFA to recognize addition? Create a DFA to recognize addition. So this is a very nice question. Let me try this. Okay. Let me tell you, before you solve this question, you should watch this video. This video you should watch. So on Go Classes YouTube channel, the link is in the description. You can find the link in the description. You should watch this video. In this video, I have created Mealy machine, Moore machine for integer addition. Okay, for addition of two integers, I have created Mealy machine, Moore machine. This is what I have created in this video. You can watch it. On Go Classes YouTube channel, you can find this Mealy machine, Moore machine, finite state machine. This playlist you can find on the Go Classes YouTube channel. In this playlist, you have total 16 videos. A lot of questions I have solved. Okay, so we have studied what is Mealy machine, what is Moore machine, how to create Mealy machine, Moore machine. Okay, everything we have seen in this playlist. You can watch it. Okay, now let's come back to the question. So the question is saying that this is your language. Your language is W. W is a string of the form x1 y1 z1 x2 y2 z2 xn yn zn for some natural number n such that x plus y equal to z as binary numbers. Okay, here x, y, z are presented starting from least significant bit. Remember, x, y, z, these are presented starting from least significant bit and can have trailing zeros. This is the question. Let's see this question. First, you understand the language, what the language is saying. The language is saying that every string is like this. The language is saying every string is like this: x1, y1, z1, okay, x1, y1, z1, x2, y2, z2, and so on, xn, yn, zn. This is your string. This is every string is like this. Every string is like this. And the question is saying that what should happen? What should happen? This should happen that x plus y should be equal to z as binary numbers. Means it should happen. See, this x is like this. This x is basically like this. And remember, this is the given. This is given x, y, z. These are presented. Starting from least significant bit. It means this is the least significant bit of x. What it means? It means this is the least significant bit of x. Okay, so first you understand the language. This is the least significant bit of x, and this is the most significant bit of x. Similarly, this is the least significant bit of y. Okay, and this is the most significant bit of y. Okay, and similarly you can notice this is the least significant bit of z, and this is the most significant bit of z. Okay, now let's understand this language. So this language is saying that basically x is like this. X is okay. So let me do this. I think okay. So now let's see. So this x is like this. X is like this. So tell me what will be x? Tell me what will be x? X will be x1, x2. Okay, should I write like that? No, it will be like this. It will be like this: xn, okay, then xn minus 1, and so on, x1. Okay, y will be like this: yn, yn minus 1, and so on, y1. And z will be like this: zn, zn minus 1, z1. This is the idea. And what the question is saying? The question is saying that x plus y should be equal to z. X plus y, this should be equal to z. Okay, so let's try to understand the question. So what the question is saying? In the question, which type of strings? First of all, you tell me in this language L, what is the length of every string? What is the length of every string? First you tell me this point. Tell me this point. What is the length of every string? What is the length of every string? You can notice the length of every string: x1, y1, z1, x2, y2, z2, xn, yn, zn. So the length of every string is 3n, correct? The length of every string is 3n, where n is a natural number. The length is 3n, correct? The length is 3n. Length is multiple of 3. Okay. And what this question is saying? The question is actually like this. So you take two numbers x, y, and you do their addition. What you do? You have x, you have y. There is a number x, there is a binary number y, and you do their addition, you will get z. Okay. And then from that you can create the string. For example, the question is like this. This question is saying that you take x. For example, let me take x 0, 1. Let me take y, that is 1, 0. Then what will be z? Tell me. If this is x 0, 1, 1, 0, then what will be z? What will be z? 0, 1, 1, 0. You do their addition, then you will get 1, 1. So z will be 1, 1. Z will be 1, 1. So which strings you will get because of this? In L, which strings you will get? In this language L, what you will get because of these? Because of these, in L, what you will get? Remember, x is a binary string, y is a binary string, and their addition should be equal to z. Read the question. Please read the question very carefully. Create a DFA recognizing the language addition. Recognizing this language. Recognizing this language where W is a string. Where W is a string of the form x1, y1, z1, x2, y2, z2, and so on for some natural number n such that x plus y equal to z as binary numbers, such that x plus y equal to z as binary numbers. X, y, z are given starting from least significant bit, and they can have trailing zeros. They can have trailing zeros, like this type of zeros they can have, trailing zeros they can have. So because of this situation, if I take x equal to 0, 1, y equal to 1, 0, then z will be 1, 1. So because of these, what string I will get in L? I will get this string in L. Okay, remember x1, y1. So I will get like this: 1, 0, 1 followed by 0, 1, 1. This string I will get in the language, correct? Yes or no? This string I will get in the language. Because of this, I will get this string. Yes or no? Starting from LSB, I will get this string 1, 0, 1, 0, 1, 1. Is it clear? Ashish, Akash, please notice, if your string is like this, please first you understand that if your string is like this, x, if x is equal to, if x is equal to like this, y is equal to like this, okay, then z will be, then z will be, then remember what we are doing? We are writing them least significant bit first. Please read this, please read this. Starting with the least significant bit, please read this. X, Y, Z, they are presented. X, Y, Z are presented starting from least significant bit. Least significant bit. Least significant bit. This is the least significant bit. This is called least significant bit. This is called most significant bit. So remember, this is called most significant bit. This is called least significant. This is called least significant bit. Okay. So your string will be like this. This string you will get in the language because of this x comma y. Because of this x comma y, you will get this string in the language. Now tell me, because of this x comma y, which string you will get in the language? If if I give you, if I give you x, let's assume x is this. Let's assume x is this, and let's assume y is this. Then what string you will get? Tell me. What will be z? Z will be what? So you do their addition. 1, 0, 0, 1 plus 0, 1, 0, 1. You do their addition. So 1 plus 1, that will be 0. Carry will be 1. Carry will be 1. 0 plus 1, that will be 1. 1 plus 0, that will be 1. So your z will be this. So because of this, which string you will get in the language? Because of this, in the language, which string you will get? In the language, which string you will get in the language? Which string you will get? So starting from LSB, starting from LSB. So first you will get 1, 1, 1, okay, followed by 0, 0, 0, followed by 0, 1, 1, followed by, okay, so followed by, remember, followed by 0, 1, 1, and followed by 1, 0, 1. This string you will get, correct or not? So because of this addition, you will get this string, correct or not? This string you will get. Yes or no? Is it clear to everyone? Let me know. Remember one more thing. Every string has length what? The length of every string is what? That is 3n. That is multiple of 3. Okay, so this string you will get 111 0 0 0, then 0 1 1, then 101. Oh, sorry. So did I do some mistake? Okay. So correct. So this will be 10. So this will be 10. So the string that I will get, what string I will get? I will get this string. I will get 110 followed by 001 followed by 011 followed by 101. This string I will get. Okay. Yes. Okay. Correct. So this string I will get. So now you are getting the idea, right? What strings are in the language, what strings are not in the language. For example, okay, let me assume if x is this and if y is this, then what will be z? Tell me, if x is this, if x is this and y is this, then what will be z? 1 plus 0, that will be 1. 1 plus 1, that will be 0, and there will be out carry. There will be out carry, that is 1. So tell me, will we have this in the language? Because of this, because of this, will we get any string in the language? In the language, are we going to get any string because of this? Will we get any string because of this? No, right? We will not get any string because of this. Because every string in this language, if you notice, every string in this language, if you notice, that has length 3n. That is multiple of 3. That is multiple of 3. Okay, so this, because of this, no string we will get in the language. Because of this, there will be no string in L. Because of this, correct or not? Because of this, there will be no string in L. Because remember, the question is saying that x plus y should be equal to z. The question is saying that x plus y should be equal to z. X plus y must be equal to z. So because of this, we cannot get any string in the language. Because of this, if x is this and y is this, then z will be 101. Now you cannot get any string in the language. So what basically what we are saying? So what is happening here? Why there is no string in L? Tell me why there is no string in L? Why? Why there is no string in L? If there is a out carry, if there is a final carry, I can say, if there is a final carry. So I can say if there is a final carry, if there is a final carry, if there is a final carry, then does not belong to language L. Yes or no? Then it will not belong to language L. Means final carry must be what? It must be 0. Yes or no? If you want to belong to L, then final carry must be 0. So how to handle this? Tell me, how to handle this? If I want this, if I want these two, if I want to do their addition, then how to handle this? Means final carry must be 0. Agree? Final carry must be 0. Final carry must be 0. Final carry must be 0. So how to handle this? Please tell me. If I want to do their addition in this language, if I want to put their addition, then what to do? Put a 0. Yes, very good. Yes, very good. Prepend a 0. Remember, the question is saying can have trailing zeros. The question is saying can have trailing zeros. Okay, so the question is saying that you can put extra zeros, you can put. Now you can do like this x you can take, this y you can take. Now the z will be 101. Okay, now everything is fine. So now what string you will get in L? Because of this, in L, what string you will get? You will get this string 101 followed by 110 followed by 001. This string you will get in the language. This string you are going to get in the language. Okay, so this is the idea. I hope this idea is clear. So did you understand the language? Let me know. Finally, did you understand the language? What this language is saying? The language is saying that x plus y should be equal to z. And you can notice the length of w must be equal to multiple of 3. Okay, the length of w, that must be multiple of 3. And you can notice these are the, you can notice this is the most significant bit of z. This is the MSB of z. and you can notice this is the LSB of x. This is the LSB of x, and you can notice x plus y should be equal to z. So what strings, tell me what strings we have in the language? We have empty string. We have empty string in the language. Why there is empty string in the language? Tell me. Why there is empty string in the language? Tell me. Because if you put n equal to 0, if you put n equal to 0, then there will be empty string. Okay, so there is no problem. Basically, if 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 0 belongs to natural number, then empty string will be in the language. If 0 does not belong to the natural number, then empty string will not be in the language. Let me assume 0 belongs to natural number. Let me assume 0 belongs to natural number. Let me assume. So you can notice empty string will be in the language. Why? Because if I put n equal to 0, then length of w will be 0. Which string has length 0? Remember, the length of w is 3n, multiple of 3. So if I put n equal to 0, then length of w will be 0. And which string has length 0? That is empty string. So this empty string you will get when you put n equal to 0. If I put n equal to 1, which string I will get? Which strings I will get if I put n equal to 1? If I put n equal to 1, if I put n equal to 1, which strings I will get? Remember, if I put n equal to 1, then which strings I will get? I will get these strings. 0 plus 0 addition is 0. 0 plus 1 addition is 1. 1 plus 0 addition is 1. These strings I will get. These I will get. This is what I will not get. 1 plus 1. This will be 1 0, and because of this there will be nothing. Okay, this does not, okay, this does not belong to language L. I can say this does not belong to language L. So what strings I will get? You can notice I will get 0 0 0. I will get 0 0 0. I will get 0 1 0. I will get 1 0 1 0 1. Sorry, I will get 0 0 0. I will get 0 1 1. I will also get 1 1. I will also get 1 0 1. So these strings I will get. Very good. Yuvraj, very good. So these strings I will get when I put n equal to 1. Then this string I will get. This string I will get. This string I will get. Okay. Similarly, if I put n equal to 2, then which strings I will get? If I put n equal to 2 in this language, if I put n equal to 2, so if I put n equal to 2, then which strings I will get? For example, this type of strings like 0 0 plus, okay, then addition will be 0 0. So because of this I will get this string. This string I will get because of this. And if I do 0 0 plus this, then I will get this string. So because of this, what I will get? Because of this I will get 0 1 1 0 0 0. This is what I will get. And similarly, you can notice if I have 0 1 plus 0 1, then what string I will get? I will get this string. So finally, what string I will get? I will get 1 1 0 0 0 1. So like this I am doing. Okay, yes or no? Like for example, 0 0 plus 1 1. So what I will get? I will get 1 1. So what string I will get? I will get this string 0 1 1 0 1 1, and so on and so on. So these strings you are getting correct, like 0 1 1 0 0 0. Okay, I can say 0 1 1 0 0 0. Similarly, I can say 0 0 0 0 0 0. Similarly, I can say 0 1 1 0 1 1. Correct? So like this. I hope you understood the language. Did you understand the language? Now we will create the DFA. First you understand the language, then we create the DFA. Did you understand the language? Can you say you understood the language? Okay, now let's create the DFA. Now we will create a DFA. When we create a DFA, what is very crucial? Actually, if you notice, apart from the numbers, these numbers x plus y equal to z, apart from these numbers, what we have to keep track of in the when you are creating DFA, what you have to keep track of? What you have to keep track of? We have to keep track of carry, yes or no? We have to keep track of carry. We have to keep track of carry. We have to keep track of. Okay, carry can be 0. Either the carry will be 0 or the carry will be 1. We have to keep track of carry. Either the carry will be 0 or the carry will be 1. We have to keep track of carry, correct? Don't forget about carry. We have to keep track of carry. So there will be one state where carry is 0, another state where carry is 1. Yes or no? We have to keep track of carry. Carry is very important. This carry is very important when you are doing addition. Whenever you are doing addition, carry is very important. For example, if you are doing addition like this, if you are if you are doing addition of these two numbers, if you are doing addition of these two numbers, then carry is very important. Carry is very important. 1 plus 1, that will be 0, and carry will be 1. 1 plus 1, that will be 0, carry will be 1. 1 plus 1, that will be 0, carry will be 1. 1 plus 1 plus 1, that will be 1, and carry will be 1. So this carry we have to keep track of. We must keep track of carry, correct? So let's create the DFA. Now the DFA creation is very easy. So there will be one state. Initially the carry is 0. Can I say initially the carry is 0? Initially the carry is 0, right? So initially the carry is a 0. So let me make initially carry is 0. Initially the carry is 0, and this is the state where carry is 1. This is the state where carry is 1. So initially carry is 0. This is the initial state where carry is 0. Okay, now tell me, in this initial state where carry is 0, if the first symbol is 0, what should I do? If the first symbol is 0, it is like this. If the first symbol is 0, like if the first symbol is 0, it means the LSB of x is 0. If the first symbol is 0. And tell me one more thing, the final carry must be what? When you are creating DFA, the final carry must be what? Tell me, which will be the final state? Final state will be what? Final state will be carry 0 state. Yes or no? Carry 0 state must be the final state, because finally carry must be 0. This we have already seen. Finally carry must be 0. So this carry 0 state will be the final state. This will be the final state, carry 0 state. Okay, finally carry must be 0. Okay, now if the first symbol is 0, then what should happen? If the first symbol is 0, then what I will do? If the first symbol is 0, then I will see the next symbol. Then I will see the next symbol. If the next symbol is also 0, then what I will do? Then the carry will be 0, yes or no? If the first symbol is 0 and the next symbol is 0, then if the first symbol is 0, next symbol is 0, then the next symbol must be what? Then the next symbol must be what? Tell me. If the first symbol is 0, okay, this is your x, this is your y. If the first symbol is 0, second symbol is 0. First symbol 0 means that this is the LSB of x. Second symbol means LSB of y. Then the result must be 0. Result must be 0. Result must be 0. So in this state, result must be 0. Okay. In this state, if 1 comes, then what should happen? In this state, if 1 comes, in this state, if 1 comes, then what should happen? In this state, if 1 comes, then I will go to dead state. Then I will go to dead state, correct? Because after 0, 0, it's like this. After 0, 0, if 1 comes, this cannot happen. This cannot happen. Because if you do addition of 0, 0, and the carry is 0, and the carry is 0, and the carry is 0, carry is 0. So the addition must be 0. So basically, if 1 comes, I will go to dead state. So if I see 0, 0, then it must be 0. After 0, if I see 1, then what should happen? After 0, if I see 1, like after 0, after this 0, if I see 1, after this 0, if I see 1, then what should happen? If I see 1 in this state, then what should happen? Then the result must be 0, because the carry is 0. Remember, carry is 0. Remember, carry is 0. Carry is 0. So the result must be 1. The result must be 1. In this state, if 0 comes, then what should happen? In this state, if 0 comes, I will go to dead state. Correct? In this state, if 0 comes, I will go to dead state. Now you can notice this state is done. This state is over. This state is over. This is dead state. This is over. This state is over. Okay, so these states are over. All these states are over. Now tell me, in this state, in the carry 0 state, in the carry 0 state, if the first symbol is 1, if the first symbol is 1, now tell me, if the first symbol is 1, in this carry 0 state, in the carry 0 state, if the first symbol is 1, then what should happen? Then let us assume second symbol is 0. If the second symbol is 0, now what should be the next symbol? What should be the next symbol? Remember, carry 0. I am talking about carry 0 state. This is the carry 0 state. In the carry 0 state, in the carry 0 state, if the first symbol is 1, second symbol is 0, then what should be the next symbol? The next symbol must be 1. The next symbol must be 1. And where will I go? The next symbol must be 1. And carry will be what? And carry will be 1. Yes or no? The next symbol will be 1 and the carry will be 1. Next symbol will, next symbol will be 1 and the carry will be 0. The carry will be 0. Okay, very simple. After 1, if the first symbol is 1, after 1, if the second symbol is 0, if the second symbol is 1, after 1, if the second symbol is 1, after 1, if the second symbol is 1, now tell me, if the second symbol is 1, after 1, if the second symbol is 1, then the result must be what? Then result must be 0. The result must be 0, but carry must be 1. Please remember, result must be 0. The next symbol must be 0. Next symbol must be 0. But now I will go to carry 1. I will go to carry 1 state. Let me know. Is it clear? See, very simple. This idea is very simple. Did you understand what is happening here? Now you can notice that this state is done. This state is done. Every state is done. Yes or no? In this state, if 1 comes, I will go to dead state. In this state, if 1 comes, I will go to dead state. So every state is done. In this state also, if in this state, if 0 comes, I will go to dead state. So you can notice every state is done. Every state is over. Yes or no? For the carry 0, every state is over. Did you understand? Anyone has any doubt? Let me know. Anyone has any doubt? What is happening here? This is what I'm saying. See, idea is very simple. Idea is very simple. Basically, if the first symbol is 0 and second symbol is 0, let us assume carry 0. Let us assume I am talking about carry 0. Let's talk about carry 0 state. Let's look at carry 0 state. So what will happen in the carry 0 state? You can notice if the first symbol is 0, second symbol is 0, then this symbol must be 0, because the carry is already, I am talking about carry 0 state, means carry is already 0, means the carry is already 0. Okay, so you can notice if I do 0 plus 0, it should be 0. It should be 0. Okay, and if I do 0 plus 0 and if I see 1, then this should go to dead state. This should go to dead state. If I see 1, this should go to dead state. Similarly, if the first symbol is 0, the second symbol is 1, then the result must be 1. Result must be 1. And this carry will be what? This carry is already 0 and this carry will also be 0. So in the carry 0 state, this is happening. What I am saying. See, very simple point. So you can similarly see 0 plus 1. If this is 0, then this will go to dead state. Then I should definitely go to dead state, because the carry, I am talking about carry 0 state. Okay, because I am talking about carry 0 state. So I should go to dead state. So did you understand this carry 0 state? Tell me, please tell me. This carry 0 state we have done. Now let's fill the carry 1 state. So we have already seen carry 0 state. This carry 0 state is already done. Okay, so this carry 0 state we have already seen. All the transitions we have already seen. Let's assume. Okay, so all the transitions we have already seen. What will happen here? Now let's see the carry 1 state. Now let me talk about carry 1 state. In the carry 1 state, now the carry is 1. Now the carry is 1. Now you tell me, if the carry is 1. So tell me, in the carry 1 state, what will happen? Tell me. Means already your previous carry is 1. Already the previous carry is 1. Already your previous carry is 1. So if you do 0 plus 0, then result must be 1. Then the result must be 1. And next carry will be, I will go to which state? I will go to which state? Tell me. I will go to which state? The next carry will be 0. The next carry will be 0. So I will go to carry 0 state. So in this carry 1 state, if the first symbol is 0 and next symbol is 0, then the next symbol must be what? The next symbol must be 1. And I will go to carry 0 state. Yes or no? In this carry 1 state, if the first symbol is 0, second symbol is 0, then next symbol must be 1. Next symbol must be 1, because this is the carry 1 state. I am talking about carry 1 state. Okay, so 0 plus 1. So that will be 1. But next carry will be 0. So I will go to carry 0 state. In this carry 1 state, this is the carry 1 state. If I do 0 plus 1, then what should happen? The result must be 0 and I will go to carry 1 state. Yes or no? So in the after 0 if 1 comes, After 0, if 1 comes, then the result must be what? Then the result must be 0, and I will go to carry one state. I will go to carry one state. Result will be 0, but I will go to carry one state. In this state, if 1 comes, I will go to dead state. I will go to dead state if in this state if 1 comes. Similarly, in this state if 0 comes, I will go to dead state. Okay, it's very simple. This is very simple. And similarly, in this state if 1 comes, in the carry one state, if 1 comes, in this carry one state, this is your carry one state. If 1 comma 0 comes, then result will be 0. Result will be 0, but I will go to carry one state. So after 1 if 0 comes, after 1 if 0 comes, then the next symbol must be 0. Next symbol must be 0. Next symbol must be 0, but I will go to carry one state. After 0 if after 1 if 1 comes, okay, remember carry one state. After 1 if 1 comes, then the result also will be 1, and I will go to carry one state. After 1 if 1 comes, then the next symbol must be 1. Next symbol must be 1. Next symbol must be 1, and I will go to carry one state. Okay, so you can notice in this state if 0 comes, I will go to dead state. In this state if 1 comes, I will go to dead state. This is your carry one state. Everything is done. So that's it. So did you understand this question? Very nice question. I hope you enjoyed this question. So finally, this is your diagram. Let me create the final diagram. Let me give you the final diagram. The final diagram is like this. See, for this question, the final diagram is like this. So you have two state. There are carry 0 state, carry 1 state. So first what you do, you create carry 0 state. So there are two states. Remember, there are two states. One is carry 0 state, one is carry 1 state. So let me create. This is your carry 0 state. This is your initial state. And this is also your final state. Because the final carry we want 0. The final carry must be 0. Yes or no? The final carry must be 0. So this is your final state also. There is another state that is carry 1 state. There is another state that is carry 1 state. Now what you can do very easily, in this carry 0 state if 0 comes, in this state if 0 comes, then if the next symbol is also 0, then the next symbol must be 1. Okay, in this state if 0 comes and next symbol is also 0, then next symbol must be 0. Then next symbol must be 0. Okay, next symbol must be 0. I can say that next symbol must be 0. Next symbol must be 0. Okay, next in this after 0 if 1 comes, after 0 if 1 comes, this is the carry 0 state. This is the carry 0 state. So after 0 if 1 comes, then the next symbol must be 1, and the carry will be 0. Okay, in the carry 0 state, in the carry 0 state, this you already know. In the carry 0 state, the carry is already 0. So the next symbol will be 1, and then I will go to carry 0 state. I will go to carry 0 state. Okay, so very simple. Now similarly in this state if 1 comes, in this state if 1 comes and then next is 0, then I will go to carry 0 state. Then the next symbol must be 1, and I will go to carry 0 state. But after 1 if 1 comes, then what I will do, after 1 if 1 comes, then the next symbol must be 0, but I will go to carry 1 state. Next symbol must be 0, and I will go to carry 1 state. Okay, very simple. And the remaining arrows, the remaining will be the dead state. The remaining things will go to the dead state. So there will be a dead state. You can create a dead state. The remaining things will be the dead state. For example, in this state if 1 comes, dead state. In this state 0 comes, dead state. Okay, so these are the dead states. You can notice the remaining things will go to the dead state. In this state if 0 comes, dead state. In this state if 1 comes, dead state. This is your carry 0. Now similarly you can create the carry 1 state. In the carry 1 state you can notice, if in the carry 1 state if 0 comes, in this state if 0 comes, then in this state if 0 comes, and let's assume next symbol is 0, then in the carry 1 state, I am talking about carry 1 state. So after this is the carry 1 state. So the next symbol must be 1. And I will go to carry 0 state. So after 0 if next symbol, okay, now in this situation what I will do, I will go to carry 0 state. So this is what I will do. In this state, if 0 comes and then again 0 comes, then the next symbol must be 1. Next symbol must be 1 and I will go to carry 0 state. After 0, if 1 comes, after 0, if 1 comes, after 0, if 1 comes, then next symbol must be 0 and I will go to carry 1 state. In this state, if 1 comes and after that 0 comes, then next symbol must be 0. Next symbol must be 0. I will go to carry 1 state. After 1, if 1 comes, then next symbol must be 1 and I will go to carry 1 state. And the remaining arrows will go to the dead state. All the remaining arrows, they will go to the dead state. Like in this state, if 1 comes, dead state. In this state, if 0 comes, dead state. Okay, all the remaining arrows will go to the dead state. So this is the idea. I hope you got it. Let me know. Anyone has any doubt in this? So finally what we have done, so you can recognize addition using DFA. So we have created a DFA which will recognize this addition. So this is your question. This is your answer. Now tell me one more thing, one variation. Let me see one variation. Let me ask you one variation. Let me ask you one variation. If this type of strings also we want to accept, this is one variation. If we want to accept this type of, if we want to accept this type of strings, for example, let us assume x is 1 0, let us assume y is 1 1, then what will be z? What will be z? Z will be 1, that will be 1 0 1. Okay, this will be z. If I want to accept this, basically if I want to accept this type of strings, basically forget about this. Okay, if I discard this, if I discard the final carry, if I discard this carry, if I discard this carry, and if I want to accept this, basically if I want to accept this 0 1 1 1 1 0, if I want to accept this type of strings, are you getting my point? Are you getting my point? This is my point, that if we just want to accept this type of strings, like okay, the final carry we will discard, but we want to accept the remaining thing. This remaining thing we want to accept. So if we want to accept this string, for example, if I want to accept this string also, like 1 plus 1, so you know that will be 0 1. If I want to accept this string, means if I want to accept 1 1 0, if I want to accept this, if we want to accept this string, then what should I do? Then in this DFA, what changes I have to do? In this DFA, what changes I have to do? In this DFA, what changes I have to do? If I want to accept, basically this final carry I will discard, this I will discard, but if I want to accept this type of strings, okay, the final carry I will discard, and if I want to accept this remaining thing, then what I will do in this DFA, what I will do? No, the carry one state will be the final state. This also will become, these two will become the final state. Both of them will become the final state, yes or no? Now, if even if the final carry is 1, that is also fine, yes or no? Basically, if the final carry is 1, that is also fine. Basically, if final carry is 1, that is also fine. Basically, final carry is 1. If final carry is 1, that is also fine. That is also fine. Okay, means if the final carry is 1, for example, you can notice 1 0 1, 1 plus 1 plus 1. Okay, if the final carry is 1, that is also fine. So I will just accept this. I will just accept this. So I will accept 1 1 0, 0 1 0, and 1 1 1. So this I will accept. Okay, this I will accept. So what I will do? Tell me what I will do. Very simple. This carry 1 also will become the final state. This is the only change. This is the only change. Okay, carry 0 comma carry 1, both these state will become final state. This is the only change. There is no other change. This is the only change. Okay, let me know, did you understand this solution, this language? Did you understand this solution, this language? So did you understand this question? The question was this, This was our question. This is the original question. You can read this question. And the question is asking, create a DFA to recognize addition. Create a DFA to recognize addition. So we have created a DFA which recognizes addition. So tell me one thing. Please tell me one thing. You have seen the solution. Okay. I told you the solution. I told you many examples. What strings are in the language, what strings are not in the language. Okay, I told you everything. Now you tell me one thing. Was this complicated to understand? This you tell me. Like, see what I'm saying. See the DFA, don't worry about DFA. Don't worry about DFA. I'm asking, this language, when you read this language, is it complicated to understand? See, the everything is given in the question. The question is very well framed. This is Boston University homework question. This is a very nice question. In the question, every information is given, that you have x, you have y, their addition must be z. Strings are given starting from LSB, starting from least significant bit, starting from LSB. So every information is given to you in the question. Every information is given to you. Every string will have length 3n, multiple of 3. Okay, so every information is given in the question. So now you tell me, did you understand the question? Did you understand which strings are in the language, which strings are not in the language? Okay, did you understand the DFA? Did you understand that the carry 0 will be the final state? Because ultimately final carry must be 0. Final carry must be 0. Yes or no? Final carry must be 0. Correct? So final carry must be 0. So carry 0 will be the final state. And carry 1 state will not be the final state, because the final carry must be 0. Okay, so then we have created transition. Very simple. In every state we are seeing what is happening. Okay, so we have created the DFA. So now tell me, did you understand all these things? And one variation also we have seen. What is the variation? If we want to accept, if we want to discard the final carry, just discard the final carry. Okay, forget about the final carry, discard the final carry. Okay, just give me the result. Just give me the n bit result. You have n bit number plus n bit number. The final result will have n plus 1 bit. The final result, it can have n plus 1 bit, but discard the final carry. Just give me the n bit plus n bit, the n bit result. You just give me that. So that is another variation. And in that variation, what will happen? The final carry equal to 1 is also allowed. We don't have any problem. The final carry equal to 1, that is also allowed. So what we will do in that variation, what we will do? We will create two final state. Final carry equal to 0, final carry equal to 1. These will be the final state in that language. Okay, in that variation. So now you tell me, did you understand? This is a very nice question. I hope you got it. No, this question will not come in the GATE exam. Arnab. Arnab is saying homework this type, then what would be the exam level question? No. This question will not come in the GATE exam. This question is not going to come in the GATE exam. This is for your practice. This is for your knowledge. This will not come in the GATE exam. Don't worry about it. But in the GATE exam, what they can ask you? They will not ask you to create the DFA. They will not ask you to create the DFA. They will not ask you number of state in the DFA. They will not ask you this. But what they can ask you? Can anyone tell me? In this question, the GATE exam, what it can ask you? It can ask you, is this regular language or not? This language they will give you, and they will ask you, is this regular language or not? So this language is regular. Okay, is this clear? This language is regular. Now let me tell you few things, few very interesting things. We have seen the DFA, but now the interesting part will come. Now the interesting part is going to come. See, many students, they by heart this statement. DFA finite automata can do addition. See, many students what they do. Many students what they do. They by heart this statement. Many students what they do. They by heart this statement. They will by heart. They will they will by heart this statement. Either this statement or this statement they will by heart in their notes. Okay, many students they will by heart from their notes. So they will write this in the notes. So they will write this type of things in the notes, like finite automata cannot do addition, cannot do addition. This type of statements they will write in the notes. Finite automata cannot do addition. So they will by heart this statement. This statement they will by heart. Okay, they will by heart this statement. The finite automata cannot do addition. Or they will by heart this statement. I don't know, like which statement they will by heart. I don't know. Finite automata can do addition. So either they will by heart this statement or they will by heart this statement. Okay. So I know I have seen many students, they either they by heart this, that finite automata cannot do addition, or they will by heart this, finite automata can do addition. Can you tell me which statement is correct? Can you tell me from these two statements which statement is correct? Can you tell me from these two statements which statement is correct? Finite automata cannot do addition, finite automata can do addition. Which statement is correct? Which of them is statement is correct? Let me tell you, both of them are nonsense. Let me tell you, both of them are nonsense. Both of them are nonsense statements. Both of them are nonsense. First of all, these are nonsense statements. Why these are nonsense statements? Let me tell you. Okay, let me tell you why these are nonsense statements. Okay, so let me tell you. The reason, let me tell you. The reason is this. After some time, we will see that this language is not regular. See, what we have seen, this language is regular, right? This we have already seen, W, okay, such that x1, y1, z1, x2, y2, z2, x2, y2, z2, correct? x2, y2, z2, x3, y3, z3, and so on. Okay, and so on, xn, yn, zn. So this language we have already seen. This is regular, right? This language we have already seen, correct? X plus y equal to z, x plus y equal to z. Okay, here you can notice x plus y equal to z. So this language is recognizing addition. This language, if you notice, this language is recognizing addition. We are recognizing addition. Okay, so x plus y equal to z. So we have already created, this language is regular. We already know this language is regular. So for this language we have already created DFA. So this DFA is recognizing addition. This DFA is recognizing addition. Okay, this DFA that we have created, that is recognizing addition, correct or not? Okay, let me tell you, after some time we will see this, because in our Go classes Theory of Computation 2023 course, so far we have seen DFA, we have seen NFA, but I will tell you there is something called pumping lemma. We will study the concept of pumping lemma, the concept of Mahil-Neror theorem, and we will see which languages are regular, which languages are not regular. One demo I have already given to you in the lectures. We have already given the proof of a power n, b power n. This is not regular. I gave you this proof. The formal proof I have given to you. Okay, very simple. The proof we have already seen. Now what I am saying, we will see another lecture where we will study which languages are regular, which languages are not regular. Okay, and let me tell you that when we study that, many students they by heart this, like which language is regular, which language is not regular. This type of concepts they will by heart. They will by heart. Okay, finite automata cannot do multiplication, cannot do comparison, 2 comparison, 3 comparison, 4 comparison. This type of things they will by heart. Many students by heart these type of things. And let me tell you that you should not by heart these things. You should understand the question, you should analyze the question, and then you should solve it. Let me give you one more thing. So you can notice this language, this is the language, and in this language we have a DFA which is recognizing addition. We have created a DFA which is recognizing addition. Let me give you another language. Let me give you another language, and this language is like this. This language is like this: x1, x2, xn hash y1, y2, yn hash z1, z2, zn, such that x plus y equal to z. Is this regular? See, please understand what is the difference. This language is regular. X1, y1, z1, x2, y2, z2, x3, y3, z3. This language is regular. This language. In this language also we are doing addition. In this language also we are doing addition, and this language is regular. Now look at this language. Look at this language. Look at this language. X1, x2, xn. Some symbol, y1 y2 yn some symbol z to z, z1 z to zn. Now you tell me such that x plus y equal to z. After some time using pumping lemma we will prove it. Don't worry about it. Don't worry about it. We will prove it using pumping lemma, using Myhill-Nerod theorem. We will prove it after some lectures. We will see this in our Go classes, theory of computation lectures. We will see this. We will see that this is non-regular. This is non-regular. There is no DFA for this language. For this language there is no DFA. For this language there is no DFA. There is no finite automata for this language. Now you tell me, so can I say finite automata cannot do? See, if you see this language, you are thinking finite automata can do addition. Yes or no? Agree or not? When you see this language, for this language we have already created DFA. For this language you are thinking finite automata can do addition, can do addition, can do addition. Now I am giving you new language, a new language I am giving you. In this new language what I have this x followed by y followed by z, x followed by y followed by z, and this language is non-regular. For this language there is no finite automata. So when you see this language, then what you will think? When you see this language, what you will think? You will think finite automata cannot do addition. So tell me which is correct. Now tell me which is correct. Tell me which is correct. Finite automata can do addition or cannot do addition? So did you understand the difference between these two languages? Remember, one language is like this. In one language what we are doing, I am giving you these three things, okay, together. Like I am giving you these three things. In one language I am giving you these three things. Okay, see, in one language, in this language what I am doing, I am giving you, first I am giving you this, okay, then I am giving you this, and then I am giving you this. Correct or not? This is what I am doing. Okay, I am giving you this. In this another language what I am doing, in this another language, what I am doing, in this another language, first I am giving you this, then I am giving you this, and then I am giving you this. So did you understand the difference between these three languages, these two languages? So this language is regular. Why this language is regular? Can anyone tell me? Because in this language, you tell me one thing. In this language, once we are done with these, see, once we are done with this, do we care about it? Like once we are here, do we care about this? Do we care about this? We don't care about this. Yes or no? We don't care about this. So once you are here, for example, once you are here, you don't care about these. You don't care about these. Yes or no? You don't care about these. You don't care about these. So what I'm saying, in this language, when I'm giving you this, then I'm giving you this, then I'm giving you this. So in this language, at any point of time, how many things you have to remember? In this language, at any point of time, how many things you have to remember? At any point of time, how many things you have to remember? At any point of time. At any point of time, how many things? You have to remember what is the carry, what is the previous carry, and what are these three. Yes or no? You have to remember four things. You have to, at any point of time, you have to remember four things. In this language, if you notice, at any point of time, four things you have to remember. You have to look at four things. You only have to look at four things. What are these? The four things are, what is the in carry, what is the incoming carry, and what is your xi, what is your yi, and what is your zi. Only these things you have to consider. You only have to look at these four things. Okay, very simple. But in this language L2, look at this language L2. In this language L2, what is happening? In this language L2, what you have to do? In this language L2, you have to remember the complete x, because first I will give you the complete x. Remember, yes or no? In this language L2, if you notice, first I will give you the complete x. First you have to remember the complete x, you have to remember. Okay, then I will give you the complete y. then I will give you the complete y. After that you have to calculate the z. After that you have to calculate the z. Can you do this? Can a finite automata do this? See, can a finite automata do this? What your finite automata will do? See, this is your L2. In this L2, first I will give you this x, then I will give you this y, and then I will give you this z. Now you tell me, what your finite automata? Okay, see, very simple. Finite automata goes from left to right, goes like this. So when finite automata is here, okay, so let's assume finite automata is here. Now it want to do the addition, yes or no? Your finite automata is here. Let's assume finite automata is here. Now this finite automata want to do addition. X is there, y is there. Now your finite automata has to do addition. But at this time, your finite automata cannot go back, yes or no? At this time, your finite automata cannot go back. At this time, your finite automata cannot know what is x, what is y. Yes or no? Is it clear to everyone? See, finite automata is going from left to right. Okay, so when it comes to z, now it needs to do addition. Okay, now you need to do addition. So you can notice that now you cannot go back, but we cannot go back. So that is the reason this language is not regular. You cannot create DFA for this language. So I hope you understood the difference between this language and this language. Okay, is it clear to everyone? So this is the idea. Now remember, now let me tell you one thing. So why this is nonsense? If you by heart, then this is nonsense. If you by heart these statements, these two statements, if you by heart, then these are nonsense. So you should not by heart these, yes or no? This is my idea. This is my point. Did you understand what point I am saying? I am saying don't by heart. Whatever language is given to you, understand that language, analyze that language, and then you find the answer. So problem is by hearting. Problem is this. Don't by heart this type of statement like finite automata can do addition, cannot do addition, can do multiplication, cannot do multiplication. Finite automata can do comparison, cannot do comparison, 2 comparison, 3 comparison, addition, multiplication, division. These type of concepts, these type of things, you should not by heart. If you understand them, then it is good. Okay, if you by heart them, then it is bad. Okay, so if you by heart, then it is nonsense. Please remember, if you by heart, then it is nonsense. If you by heart, then you will make a mistake. If you by heart, then you will make a mistake. Okay, so if you don't by heart, if you by heart, then you will make a mistake. And if you don't by heart, then you can solve the question. Whatever language is given to you, you can solve it. For example, if this language is given to you, then you will say, though, so this is non-regular. In this language, addition is happening. In this language also addition is happening. But this language is regular because in this language, we are only thinking about 3 things at a time. Okay, only 3 things at a time. Only 3 things at a time. Okay, so in this language, if you notice, we are looking at 3 things at a time. At a time, we are looking at 3 things. Okay, 3 things at a time in this language. I hope this point is clear. But in this language, you can notice first entire x, then entire y, then entire z. So this language is non-regular. Okay, so that's it. So this is the final point. Now the final point. Okay, if this statement is there, finite automata can do addition. Finite automata can do addition. So what will be your answer? Finite automata can do addition. Finite automata can do addition. What will be your answer? The answer will be yes. Yes, finite automata can do addition. DFA can do addition. Okay, because, but what you have to do? For this addition, what you have to do? The answer will be yes. Finite automata can do addition. The answer will be yes. The answer will be yes. But if finite automata has to do addition, if finite automata has to do addition, then what should happen? if finite automata has to do addition, then what should happen? You should give me like this. The input should be given like this. The input must be given like this. The input must be given like following. So the input must be given like this. Okay, means you should give me input like this: x, y, z. This is your x, this is your y, this is your z. Now the input must be given like this. Like this, the input must be given. Okay, so first give me this, then give me this. So this is the idea. Then give me this. Okay, so the input must be given like this. The input must be given like this. Okay, so that's it. So if anyone asks you finite automata can do addition, yes, it can do addition, but you should give the input. But remember, the input you should give like this. Okay, you should give the input like this, like whatever input you have. For example, if your x is 1001 and if your y is 0111, then what will be z? Z will be 0 0 0. Okay, so let's assume this is also 0. So what will be your z? Z will be 0 0 1 1. This will be z. Now, so the input, if you give input like this, then finite automata can do addition. See, if I give, if input is given like this, if input is given like this, like if I give input like this, 110 followed by 010 followed by 001 followed by 101. If I give input like this, then yes, finite automata can do addition. Yes, FA can do addition. FA can do addition. But if you give the input like this, if input is given like this, if input is given like this, first you give x, then you give y, and then you give z. If the input is given like this, then finite automata cannot do addition. So if input is given like this, remember, if input is given like this, okay, then finite automata cannot do addition. Okay, so that's it.